Question 2. Nitrogen reacts with the hydrogen in Haber process as shown in the reaction 1, and the delta H that given is XO, so it's negative X kilojoule per mole. From these informations already telling us that the forward reaction is XO, release energy, which means the reverse reaction must be endothermic, absorb energy. So this is a very important hint that given in the question. Now, in the table 2.1, there are 3 equilibrium mixture, A, B, C. So later we refer to this table to solve the question. Part A. Describe and explain the change, if any, to the percentage yield of ammonia produced in B compared to A. Now we just compare the B and A, these two. So just try to get their different. Everything same except this one. So in Haber process, we know that iron is a catalyst. Equilibrium mixture A, no catalyst. B, it has catalyst. So now, the part A asking per percentage yield of the product. So you all need to know catalyst will not affect the yield. It will just it will affect the rates of reaction to make it faster or sometimes slower. So therefore, we know that for the reaction or equilibrium mixture of these A and B, the percentage yield of the ammonia is no change. It will stay the same. So because they are different, it just with catalyst and without catalyst. So therefore, the percentage yield again for the B, it will same as A, which is 58. And this is because catalyst will not affect you. Part B1. Describe and explain the change, if any, to the percentage yield of ammonia produced in C compared to A. Now let's compare the C and A. They are different is the temperature. So C, the temperature is higher than A. So now it's asking again the percentage yield of the ammonia in C. Then we need to refer to the enthalpies that given, because in this question initially already told us that this reaction is exothermic. When temperature increases, the equilibrium will try to reduce temperature by moving backwards. Because moving backwards is endothermic, it will absorb the heat. Therefore, when temperature increases, equilibrium shift to left, the products will getting lesser. So the yield will decreases. That's how you explain or how you give the yield of this ammonia in C. So the percentage yield of the ammonia produced in C will be lesser than A. Okay, so this one is the one that you need to state. Then you explain. It is because, very easy, you just use the enthalpies to explain. Because the forward reaction is exothermic. It's because the forward reaction is exothermic, therefore reverse is the endothermic. So it will shift to left hand side and absorb the heat, right? So the reason is because of this. The forward reaction is exothermic. Part 2. Describe and explain the change to the rate of forward reaction that occur to establish the equilibrium in C compared to A. In this explanation, you no need to refer to Boltzmann distribution. Let's compare the C and A. We just discussed the difference between C and A. C, the temperature is higher. A, temperature is lower. So temperature, first it will affect the kinetics energies of the particle. So therefore, first you need to mention the effects of the temperature. So the temperature used in the C is higher, and therefore the particles will have the greater kinetics energy. This is the one that you need to describe or state. After that, you just explain. So because of this higher temperature and the greater kinetic energy, so there will be more collision between the particles that have the energies more than the activation energy. And this one will cause the increase in the frequencies of effective collision. Because not all the collisions, they are effective collision. Because now there are more collisions, okay, between the particles that have minimum EA. So therefore, also it will cause the increase in the frequencies of effective collision. And therefore, the initial rate for the forward reaction will increase. This is how you explain about the effects of temperatures on the rate. In summary, it's just higher temperature, higher kinetic energy, then the rate is increases. C part 1. Write an expression for the equilibrium constant Kp. Kp is about pressure. Yeah? So do not put the square bracket, which is the concentration. No. So you must use the partial pressure. And of course, you need to state the units in this question. So Kp is the partial pressure of the ammonia square over the partial pressure of nitrogen times partial pressure of hydrogen cube. If you want to use or refer to the equation, yes, you can. So the power is follow the coefficient of the reactants and products. So because ammonia, the coefficient is 2, so it's square. Right. For the hydrogen, coefficient is 3, therefore it's cube. And the units for this Kp, you can use this ATM, because it's given because in the question is just ATM, so refer to the pressure is in ATM, so you just use or refer to this table 2.1. So it's ATM square over ATM power 4, so eventually you'll get ATM power negative 2. For the part 2, this part is calculations that it's better for you to use the ICE table. Then you can get the moles and the mole fractions easily. Okay, so let's start the question. Equilibrium mixture D. So D means it's not really in the table now, it's another new equilibrium mixture. Is made when 1 mole of nitrogen and 3 moles of hydrogens are added to a sealed container. Temperature is 750 and 1000 atm, and we just left it to reach equilibrium. And after that, after it's reached equilibrium, the mixture contains 1.16 mole of ammonia. So from this information, you can construct the ICE table. You can just use the mole instead of the concentration. It's okay. So for the I initial, so it's 1 mole of nitrogen, 3 moles of hydrogen. Ammonia still not yet formed, 0. For the equilibrium, already given 1.16 mole of ammonia. So from here, we can do the comparison, or we can use the mole ratio. For the change, ammonia is plus 1.16. For the nitrogens and hydrogens, they must minus, means they must reduce. Because the nitrogens and hydrogens, they must react to form the ammonia, right? Therefore, their moles must decrease. Decrease by how much? So it need to depends on the mole ratio. So because the mole ratio between this nitrogen and ammonia is 1 to 2, so when this ammonia plus 1.16, nitrogen must minus 1.16 over 2, because it's 1 to 2 ratio. For the hydrogen, we use the mole ratio again. So it must minus 3 over 2 times 1.16, because the ratio between the hydrogens and ammonia is 3 to 2, right? So we use 3 over 2 times 1.16. So eventually, at equilibrium, we'll get the moles of the nitrogen, hydrogen, and this is given. So this is how we get all the moles, yeah? Right? Okay, again, the moles of the nitrogen at equilibrium, so we just sum up the I and C, we sum it up. So means it's 1 minus 1.16 over 2. So we get 0.42. The moles of hydrogen is 3 minus 3 over 2 times 1.16. We get 1.26. Now the total mole, we just sum it up. We get 2.84. Okay, then we can get the mole fractions of the ammonia. Mole fractions of ammonia, we need to use the moles of ammonia at equilibrium over the total mole. So we get 0.408. Part 3. The mole fraction of nitrogen is 0.625 in the new equilibrium E. This is another equilibrium. Calculate the partial pressure of nitrogen in E when total pressure is 1000. Very easy. So you just need to remember, to calculate partial pressure, we use the mole fractions times total pressure. Since the mole fractions already given, 0.625, total pressure is 1000, so we will get 625 atm. For part D, when oxide of nitrogen escape into the atmosphere, they may involve in two processes: formation of acid rain from sulfur dioxide, formation of photochemical smoke. Part 1. Identify the role of the nitrogen monoxide and nitrogen dioxide in the formations of the sulfuric acid from the sulfur dioxide. Use the relevant equation to support your answer. Very easy. First, you need to get the role of these two oxides. So the NO and NO2 is the catalyst, because it can be regenerated after the reaction. So you need to give these two equations. Nitrogen dioxide will oxidize the SO2 to form SO3. Itself will reduce to NO. Then the NO will oxidize by oxygen and form back the NO2. And this NO2 will use back for the first reaction and form the SO3 again. So because it can regenerate, so we say that these two, they are catalysts, which to catalyze the formations of the SO3 from SO2. So these two equations you must give, right? And after that, you must explain, or you give the equations how the sulfuric acid or the acid rain form. after the SO3 produced, the SO3 will react with water to form the sulfuric acid. Okay, you can explain like this, or you can just give the equation. Part 2. Outline how NO and NO2 may contribute to the formation of photochemical smog. This one is very common now, and this photochemical smog is the environmental issue. The chemicals that cause this photochemical smog is the peroxyacetyl nitrate. In short form is PAN. In exam, you just give PAN. It's okay. If you cannot remember the full name, you just put PAN. Right? So how to form this PAN? When the nitrogen oxides combine with the unburned hydrocarbon, means it's from the petrol, those unburned hydrocarbon will combine with this nitrogen oxide, of course with the sunlight, then it will form this PAN. Okay, that's all. Thank you.